Hi Year 10, Mrs. Smith here, and today we're learning about oxidation and reduction. So do it now, task my daily task, pause the video, go do it now, then come back and we'll talk about oxidation and reduction. Hi Year 10. So today we're looking about oxidation and reduction. Just want you to have a little think, what do you think oxidation might mean? Yeah? What do you think it might mean? I'm hearing some good answers here. That's right. When a metal is oxidized, so here's a little metal atom. When a metal is oxidized, you're right, we add oxygen to it. There you go. So we've now gone from the metal to a compound. We have oxidized it. We have added oxygen. So if oxidation means adding oxygen, what do you think reduction might mean? You've got it. Reduction is reducing the amount of oxygen or removing the oxygen. So this is oxidized. This is reduced. I've taken the oxygen away. Let's take a look at what it would look like in the book. Okay, so I've got our definitions written down. Oxygen is adding oxygen. Reduction is removing oxygen. And here's an example of oxidation. Iron and oxygen makes iron oxide. You might know this as rust. So when iron rusts, what happens is it corrodes. And corrosion is when a metal is oxidized, when it reacts with oxygen. It is only called rust in the case of iron. It is called corrosion in the case of every other metal. You may have noticed that these two equations, your iron and oxygen making iron oxide, the rusting, the corroding equation for the oxidation, and the aluminium oxide can be reduced by, the aluminium can be reduced by splitting it up into aluminium and oxygen. You may have noticed that these aren't balanced. Pause the video and balance the equations, please. Okay, so here we go. We have got two oxygens here, which means we're going to need two iron oxides. If we've got two iron oxides, we're going to need two irons. For the aluminium one, we've got our 2 and 3 problem again. So we're going to have to make it up to 6. So we're going to need 6 oxygens on this side, which is 3 O2s, and we're going to need 6 oxygens on this side, which is 2 O3s. That means we've got 2 lots of 2 aluminium, 4 aluminium in total. There we go. Okay, so when we do this, we can say that iron is oxidized for our first equation, and for our second we can say that aluminium is reduced. Okay, so why do you have to know this? Why is this useful? Why is it needed? Well, you need to know it because you need to be able to use the words to describe the world around you. You can see iron rusting, corroding, being oxidized. When you look at metal gates, for example, we can talk about why we use things like stainless steel for cutlery instead of something that would corrode or rust. We can, so when we are looking at which materials to use for what, are we going to want to use a metal that is going to corrode? Because when it corrodes, when it reacts with oxygen, it gets really brittle and you get little holes in it. I'm sure you can see if you've got a thin layer of rust. And if you had, say, a drinks can made out of something which reacted and corroded all the way through, then after a couple of months, your drink would come falling out of the can, so it wouldn't be that useful. So we need to know how things corrode, and how we can stop them from corroding, how we can reduce the corrosion. Yeah, it's basically all about keeping everything shiny. Okay, we want it to shimmer like a wealthy woman's neck. Okay, we need it shiny because shiny metals mean that metals are working well. Now there is an optional practical for you to do. I am linking you to another video for that because I did that for another class experiment, so you get to see that, and you can do this, and it's basically about trying to get nails to rust so you can see the corrosion. So I'll be sending you the link to that video as well. It's on my channel if you want to browse as well. Okay, one last thing. Those of you doing higher paper, you may well remember, if I just turn back a few pages. Yeah, here you go. We talked about here oxidation and reduction, and we said that oxidation is loss of electrons and reduction is gain of electrons. That hasn't changed, okay? It's still the same. Oxidation, when you add oxygen to a metal, okay? So here's your metal, okay? Oxygen comes along, and instead of being a metal, this would become, say, iron 2+, and your oxygen would be 2-, and it would be ionically joined. It would be the electrostatic attraction between those oppositely charged ions. So although we've added oxygen, the oxygen has swooped off the electrons. Okay, and when we reduce it, when we remove the oxygen, the metal gains those electrons back. Okay, so it's not changed. You just have to know, if you're doing higher paper and only higher paper, you have to know both definitions. You also have to be able to write the half equations, just as we did here. Okay, so for higher, let's do some half equations for our oxidation ones here. Okay, higher paper. We have got, let's oxidize it first. Two ions will make 2 iron 2+, and we're going to have 4 electrons. Okay, because you've got 2 lots of 2+, so each ion would have had, each ion would have had to lose 2 electrons each. And this would be the oxidation. If we want to do reduction, okay, and we'd then do aluminium 3+. We've got 2 of them, so we're going to need 6 electrons. Yeah, and that will make we've got Al2 there, so I'm not using the big number there, sorry. Then we're going to make 2 aluminiums, okay, because we've soaked up those electrons. So this is reduction. Okay, so it's still the same. It's still the oxidation and reduction that we talked about a few lessons ago. However, we are now looking at it as if you have added oxygen, it's oxidation, removed oxygen, it's reduction. It's slightly easier to spot, but you do still have to do the half equations for it. So that's pretty much it for oxidation and reduction. It's not, so I don't feel it's a difficult concept. If you feel it's a difficult concept, please let me know. Please ask questions. But that's pretty much all there is to it. So have a go at the worksheet. Tell me if there's anything on it that you can't do or you struggled with, and I'll see what I can do to help. All right, take care, Year 10, and see you very soon for another exciting chemistry lesson. Bye.